So, objective 1 is what we're going to cover. Okay, at the end, the very last slide says review objective 2 on your own, page 39 if you need to. That's the last slide. But I do want to go over objective 1, and that has to do with determining if an expression is a polynomial. Polynomial is an algebraic expression with certain qualities. If it doesn't happen to meet the characteristics that are required to be a polynomial, it's still a legitimate algebraic expression. It's just not a polynomial. Okay. So here are there's two criteria to eliminate an algebraic expression from being a polynomial. The first one is that no variable can be in a denominator. If you have a variable in a denominator, it cannot be a polynomial. It's a perfectly legitimate algebraic expression. It's just not a polynomial. The second part means the same thing. If you have a variable raised to a negative power, in reality that means there is a variable in a denominator. So if you see a variable raised to a negative power, if you see a variable underneath a fraction in a denominator, it cannot be a polynomial. The next thing to look for is you cannot have a variable in a radical or under a radical. Another way to think about this is if you have a variable raised to a rational power, that's not a whole number, to the 1/2 power, 1/3 power, that kind of thing, okay, then it can also not be a polynomial. Those are your keys. Those are your look fors. If you don't see any of that going on, it's a polynomial. Okay? So, what I'm going to put up next are some examples. I want you to decide which are polynomials, write them down, take a picture, however you want to do it, and decide which ones you think are polynomials and which ones are not polynomials. Then we'll come back together and decide if you are right or wrong. Which one? Raise your. Okay, let's go through it. Let's go through them. Which one do you? How many of you think number 1 is a polynomial? Raise your hand if you think 1 is a polynomial. Okay, lots of hands. How many think 2 is a polynomial? Raise your hand. How many think 3 is a polynomial? How many think 4 is a polynomial? Very good, class. These are both polynomials. These are not. Okay. This one has a variable under a radical. This one has a variable raised to a negative power, which means it's really in the denominator. I will say that sometimes people say this one is not a polynomial because of this 1/3. Keep in mind whether or not something is a polynomial has to do with the variables. So this x squared, if I was to bring it together with this fraction, it would actually go on top, not on the bottom. Okay, so good job. That's the first thing. The second part of this lesson has to do with degree. And you've learned about degree in the past. And in order to talk about degrees of polynomials, we must be able to first figure out the degree of a monomial. Okay, and simply stated, the degree of a monomial is just the highest power on the variable. That's the key. It's powers on variables. Doesn't matter about power on constants. Powers on variables. Okay. Here's some examples. Write those down and write the degrees for each term, please. What is the degree of this term? 2. What is the degree of this term?
5.
And this one?
3.
That is correct. Let's talk about a couple other situations though. Let's say I had this was just the number 8. What is the degree of that term?
1.
2.
0.
0. 1. Wait, no, it's 1. Yeah. 1.
What?
1.
What is the power on the variable?
No,
It's nothing.
There is no variable.
Oh, you're so stupid.
There is no variable. If I had degree 1, let's say I had this. That would be degree 1. Okay? Again, it's all about the power on the variable. So if you have a constant, no variable, you could think of it as, an x to the 0 power, which is 1. So 1 times that is still going to give you the constant. It's all about the variable. Okay? Next thing. Sometimes you will have terms that have more than one variable in them. Sometimes you'll have expressions or polynomials that have more than one variable in them. If you have that, you add the powers together of the variables. And that's how you determine the degree of the term. when there's more than one variable. Okay, so on the next slide, I'm going to have a couple monomials with multiple variables that you're going to have to find the degree of. Here are two examples. Find the degrees of those two terms. What is the degree of this term?
3.
3, because the power on y is 1. Add them together. What's the degree of this term?
6.
Very good. Simple enough. Okay. So that's the easy part. The next part is still not hard actually. Is finding, so we found degree of a monomial, one term. Now we're going to look at degree of an entire polynomial. Okay? And when you have an entire polynomial, what you have to do is find the degree of each term first, and whichever one's the highest is the degree of the whole thing. Think about when we did quadratic equations back in the day, okay? The highest power for a quadratic was always what? 2, okay? But then we had an x term that had a power of 1. We usually had a constant term that has a power of 0, okay? So in that case, the highest power was 2. So a quadratic has degree 2, right? Whatever the highest one is. And so that's what this says. The highest monomial degree is the degree of the whole thing. So when you find all the individual degrees, whichever one's the biggest is the one that's the degree of the whole thing. One more term that we need to know is the term leading coefficient, the phrase leading coefficient, okay? Remember, coefficient is the number in front of the variable. And the leading coefficient is the coefficient that goes with the term that has the highest degree. Okay? The reason it's called leading coefficient is typically what we do is we put polynomials in what's called descending order, where the highest power comes first, then you move your way to the right, going down one at a time. So for example, if you had a 4th degree polynomial, the 4th power would be the first term, then the 3rd would be the 2nd would be the 3rd, the 1st would be the 4th, and the 5th term would just be a constant. Okay? So when it's in descending order, it's the one that comes first. However, a lot of times polynomials will not be in descending order, and you don't necessarily have to put them in descending order to find the leading coefficient. It's just the one that goes with the highest degree. Okay? So here are some examples. Okay, we're going to find the degree of each polynomial, which they're both polynomials, and then we're going to find the leading coefficient of each polynomial. Okay? Here's what we're going to be doing for just the first one, then we'll do the same thing for the second one. All right. What is the degree of this polynomial? Okay, like what's the degree of this term? 2. So the highest one is 2. Means the whole thing is 2. In this case, it does come first. So the leading coefficient is the one that goes with this and is in front. So it is 4. Okay? Do the last one. Degree and leading coefficient. All right, degree. Dom, what do you have for degree for this term? So the degree of this term is what? 4? 4, 6. So the degree is 6. The leading coefficient is the one that goes with the degree 6, which ends up being, okay? Any questions about any of objective 1? That's all objective 1. Here is objective 2. Adding and subtracting polynomials. See page 39 if you need a refresher. Watch your signs. Distribute properly. All kinds of stuff that you already know how to do.